If one day in the future, technology is advanced enough, you can travel at the speed of light in a spaceship. This is you holding up a mirror inside a dirigible. So can you see yourself in the mirror? When we usually look in the mirror, light shines from the face into the mirror, and it's reflected back into the eye. But here's the thing. When the ship moves at the speed of light, it travels with the ship at the speed of light. The light that shines from your face never catch up with the mirror. So from this perspective, you can't see anything in the mirror. But some people think this explanation is wrong because the ship itself travels at the speed of light. Everything in this ship, including light, is related. So the speed at which the light on your face hits the mirror at this moment, it should be the speed of the spacecraft plus the speed of light. So it doesn't affect his reflection in the mirror. You can see yourself in the mirror. Which of these two explanations do you think is correct? Could have seen, or you can't see, even if you can't verify it yourself. But the result is nothing more than a choice. At least I have a point. But the bad thing is that someone did an experiment. Let neither explanation make sense. To avoid the influence of inertia on light, he starts with a fixed laser, light speed meter on camera car. If the car is moving forward, then the relative speed of the car and light decreases. So the numbers on the meter must get smaller. Driving backwards increases the number. It can be used in actual experiments, no matter how the car moves. The results on the measuring instrument have remained unchanged. Even when the light source and the car are in motion, the result is still the same. Something more scientific and precise. Scientists have done it countless times, and they came to an outrageous conclusion. That is light for any object. The speed is constant. This is the speed of light in chivalrous relativity. How outrageous is this conclusion? That is to say, if I were outside the spaceship, watch you fly a spaceship, chasing light at 99.9% of the speed of light. I see that the speed of light is of course the speed of light. That's 300,000 kilometers per second. Light is only 0.1% faster than you. But from the perspective of the spacecraft agent, you will see light also leaves at 300,000 kilometers per second, not just 0.1% faster. Then why did the two of us see the light? Will they contradict each other? In a minute, you'll understand why. You stand on a truck and look in the mirror, and I stand on the roadside tower looking at you. From your perspective, after you open the spotlight pen, you will see a camera mirror with straight light, and it's reflected back onto the body. But for me in the tower, due to its forward movement, and what I see is that the actual path of light looks like this. I see the distance the laser travels, longer than you see. The previous experiments demonstrate that. The speed of light is the same for all of us. Constant speed. It gets longer. That means I spend more time than you. That is on this same journey. Your time is slowing down. That's the time dilation effect of motion. If you are interested, just use the Pythagorean theorem you learned in junior high school. It is easy to calculate the time expansion. How much did it swell? Often high-end ingredients. Only the simplest cooking methods are required. If you figure it out and verify it later, you will find that haha is not right. Suppose the spaceship races against light at 0.5 times the speed of light to a location 300,000 kilometers away. I see light in 1 second. The spaceship took 2 seconds, but due to the time dilation effect, your time in the ship passes more slowly than mine. You see yourself going for 1.7 seconds, reached the destination. So here's the problem. 1.7 seconds times 0.5 times the speed of light. That is, you go from the starting point to the destination is only 260,000 kilometers away. Why do I see you driving 300,000 kilometers? And your spaceship, it only shows that it has advanced 260,000 kilometers. That's the scaling effect, because exercise doesn't just affect time, it also affects the space. 300,000 kilometers at rest. The moment you accelerate to 0.5 times the speed of light, you haven't started exercising yet, but you can see intuitively that the entire universe is being squashed. Change the distance between you and the target to 260,000 kilometers. And in my opinion, the universe didn't change, you suddenly flattened. The faster it goes, the flatter it looks. So as a boy, be sure to know about the scaling effect and time dilation, because he clearly told us. Time and length are relative. You have no reason not to be confident. Answer the question about the title of the video. When you look in the mirror on a lightspeed spaceship, what will happen? If the spacecraft is headed for Andromeda Galaxy to 0.5 million light years away, for people on Earth, you'll have to drive to 0.5 million years to get there. And for you, the moment the spacecraft enters the speed of light, the size effect and time dilation effect are extremely apparent. From your perspective, the entire universe was flattened into a two-dimensional plane. Distance and time do not exist. You're suddenly in the Andromeda Galaxy. Don't stop now. Immediately return to Earth at the speed of light. When you arrive on Earth, your parents are 5.08 million years old, and you're as young as you were when you started. So the most important thing to do now, just call home and say hello. So to sum up, since the spacecraft is traveling at the speed of light, it doesn't take time. There's no looking in the mirror. Can you see your own problems? Just like you asked if the result is yes or no, but the answer is no. As for why it didn't take time, it boils down to the constant speed of light. Then why does the speed of light remain the same? No one in the entire solar system. But that doesn't stop us from thinking and exploring the universe. The author of Chivalrous Relativity is Einstein, but few people know that he was very passionate about sailing and used to own two sailboats. He said it was safest to have a boat at the dock. But that's not what ships are built for. The unknown is like the ocean, and science is like a battleship at sea. There's no telling who's dead on Star Trek. Younger predecessors did not set the stage.